I request Nasir Ali sir to be in chair. Welcome you, sir. Nasir Ali sir. Okay, welcome you.
Thank you, sir. Shall we begin?
Yes.
Okay. Good evening, everyone. I'm Dr. Nasir Ali MK, Head of the Department of Education, Majlis Arts and Science College, Autonomous, Puramannur. It gives me immense pleasure to welcome you all to the 6-day online faculty development program sponsored by AICTE Training and Learning Academy, Atal, on the theme Empowering Educators with Next-Gen Computing, AI, Supercomputing, and Data Science. This FDP is scheduled from 24th November 2025, that's today, to 29th November 2025, organized by Department of Computer Science and Applications of Majlis Arts and Science College. I am delighted to welcome the 234 participants who have joined us from various institutions across the country. We deeply appreciate your interest and commitment. I wish each one of you a highly conducive learning and growing environment where you can explore new ideas, collaborate, and enhance your understanding of next generation technologies. It is now my privilege to introduce today's distinguished resource person for session 1, Dr. Shailesh Shivan. Dr. Shailesh Shivan is a renowned educator and researcher, known for seamlessly integrating academic depth with industry perspective. He currently serves as the principal AI architect at Lenac AI India Private Limited, a UK-based company, while on academic leave from his role as assistant professor in the Department of Computer Science, Cochin University of Science and Technology, CUSAT. He holds a BTech Computer Science and Engineering, an MTech in Computer and Information Science, and an MSc in Mathematics. He completed his PhD from CUSAT, producing pioneering research on AI techniques for analyzing classical dance. With over 9 years of academic and research experience and 5 years of industry experience as a senior software engineer, he possesses rich expertise in AI, deep learning, machine learning, NLP, computer vision, soft computing, quantum computing, and knowledge graphs. He has supervised 4 PhD scholars, qualified UGC NET, JRF, and GATE multiple times. Authored the celebrated book titled Algorithmic Thinking with Python, and published 50 plus research papers in reputed journals and conferences. His contributions also include 2 granted patents in advanced AI applications, with experience as a resource person for 180 plus workshops and seminars. Dr. Shailesh Shivan is widely respected as a dynamic academic leader. Today, Dr. Shailesh will lead session 1 titled Bridging the Gap, Integrating Next-Gen Computing into the Curriculum. I also take this opportunity to welcome our resource person of the first session in the faculty development program sponsored by Atal, Dr. Shailesh Shivan, sir, to this session. Welcome you, sir. I also extend a warm welcome to Dr. Muhammad Kuti Kakakunnan, Principal of Majlis Arts and Science College Autonomous, and the coordinator of this faculty development program. Welcome you, sir. Mr. Rafiq, who has been working for this program in the capacity of co-coordinator of the faculty development program and as an IQAC coordinator of the Majlis College. Welcome, Mr. Rafiq, sir. Mr. Naushad Yen, who is the director of Majlis Arts and Science College, is there. I take this opportunity to welcome him to this session. There are many other dignitaries present online for attending this session. I welcome all whose names were not mentioned to this session. My greetings additionally to the rapporteur, Mr. Mohammad Jaber PK, and to Ms. Manjula H, who will deliver the vote of thanks. Both of them are assistant professors in the Department of Computer Science and Applications of Majlis College. With great pleasure, I welcome all of you once again to this Atal FTP. Let us look forward to an inspiring, insightful, and intellectually vibrant 6 days of learning. Thank you very much. Welcome again to everyone to this session. Over to you, sir.
Am I audible properly?
Yes,
Hello?
sir.
Yes.
Yes, sir. Shailesh, sir. You're
Yeah.
audible.
So let me share my screen first. I've sent a request to turn on my screen. Can you please accept
Yeah,
it?
it will be okay now, sir. You can share.
Is the screen visible to you?
Yes, sir.
Yes, sir.
So can we start?
Yes, sir.
Okay. Thank you. So first of all, I would like to thank Department of Computer Science and the college management for inviting me as a resource person for this prestigious Atal FTP. And I'm very glad that the opening session is handling by myself. And the topic we are actually going to discuss today is bridging the gap, integrating next-gen computing into the curriculum. So I think this particular topic is very much aligned with the main theme of this particular FDP because we have to get into the space of technology for developing our curriculum for the future needs. So I'm just taking this opportunity to make an initiative or make an attempt to introduce what all things are actually happening in the next gen computing arena and how we can actually incorporate these techniques into our curriculum for developing a better future educational platform. So this is the outline of the talk. We will be starting with an introduction, then we will look into what is the next gen computing and what are the next gen computing domains and how we can understand these domains and what are the challenges in traditional curricula, then principles of integration for this next gen computing into our current educational curriculum, then what framework we can actually follow for integrating this and the teaching learning enhancements, then implementation model, faculty development initiatives, and we are ending up with a conclusion. Okay. So as an introduction, I would like to to tell why we need to go for this talk. Okay. See, as the name of the FDP suggests, the next gen computing, right? Next gen computing. So, what is actually the need of thinking about next gen computing? So, I will like to start with an opening quote like, computing is actually no longer just a discipline. Computing is actually no longer just a discipline. It has become a fundamental tool for exploring and advancing every other discipline. That is the key thought when I am thinking about this particular topic. So our educational systems are actually experiencing rapid technology shifts, right? After the big pandemic happened in the past years, we 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 are actually able to understand the traditional educational systems can be very much altered in different ways. See, we were not even thinking about we can attend the classes from our home, right? The students are actually attending classes from their home. The teachers are teaching them from their homes and all, right? But it happened to different technology platforms. So the educational systems are now experiencing rapid technology shift, and the introduction of ChatGPT kind of generative AI tools had made a big change in the perception of actually education system itself. So also the industry demands, the demands of industry is actually not even different. They demand skills in AI, cloud, cybersecurity, quantum computing, the virtual reality, extended reality, and edge computing technologies, irrespective of the domain the students are actually pursuing. And regarding the perspective of students, or the regarding the expectation of students, we can see that the students are now smarter than teachers, right? Because they are more exposed into advanced technologies. So the students are expecting more modern learning experience comparing, rather than sticking into the traditional teaching learning practices. And the curriculum upgradation, one of the pain we are actually always facing is our curriculums we are following are not even comparable with what these requirements are actually demanding, right? So how the curriculum upgradations can be done, and how we can make it competitive or competent with the global requirements, right? So this is why I have chosen this particular topic for engaging you for this 1.5 hours. Okay. So what are the global trends in computing education? When it comes to computing education, so as I said, it is not a discipline now. It is actually a basic tool for all domains, right? So the computing, or particularly the AI and related domains, become foundational across all domains. And the cross-disciplinary computing perspectives actually emerging in a very strong manner. We can see the applications of AI, or the even traditional computing techniques in every domain, like in social sciences, agriculture, medicine, physical education. Everywhere we can actually see the impact of computing, or the involvement of computing techniques for advancing that particular domain. And the higher demand for hands-on and project-centered learning is again a very core requirement for putting the computing aspects in curriculum. And we know the institutions are now adopting micro credentials and online learning systems. And to develop these kind of new gen teaching learning practices, also we need to put the computing as one of the prominent tool in curriculum with all the computing, all the domains. Okay. So what is next generation computing? So next generation computing refers to transformative technologies that redefine computational paradigms, learning approaches, and real world applications. So if you think about what all things actually coming under the next generation computing, you can see that starting from artificial intelligence, machine learning, data science and big data engineering, quantum computing, edge computing and IoT, extended reality, including the augmented reality, virtual reality, and mixed reality, then cyber physical systems and robotics, cloud native technologies, and agentic AI and autonomous systems are actually going to transform our future in a very fast phase, and in a very fruitful technology uh, advancements way. Okay, so what all things are actually happening in these domains, what all things we need to understand about these domains, and how we can actually incorporate these technologies into our curriculum for applying those techniques in the for the advancement as well as for enriching our own domain. Okay, so we can just start with artificial intelligence itself. So before getting into artificial intelligence, to make it interactive, I just want to ask you, what is your perception about human intelligence? Can anyone unmute and tell me what is human intelligence? What is your idea about human intelligence? See, as it is an online session, I want to make it interactive because I am not seeing your faces and I don't know how much you are perceiving this. So to make it little interactive, can anyone unmute and tell me what is your perception about human intelligence?
The ability to learn and use that information for future decision making and all.
Yes, the ability to learn and making decisions. Okay. Anyone else?
Taking decisions
Yeah.
impromptly, like
Okay.
making decisions very quickly, real time, quickly.
Okay. Yes. And thank you for thank you for your perceptions. And I want to make it more clear and elaborative. So human ability or human intelligence, it is the ability of a human to apply his knowledge to solve a problem in real situation. Okay. So it is nothing but the ability of a human to apply his knowledge to solve a problem in real situation. And the problems we are actually solving with our intelligence may include reasoning, decision making, optimization, and even generating contents, right? So comparing to this particular definition of human intelligence, I can also define or I can also make you understand what is artificial intelligence. So artificial intelligence is actually nothing but it is a branch of computer science that focus on inducing intelligence into machines and systems by leveraging data and algorithms. AI systems enable systems to reason, learn, make decisions, and optimize, process, and even generate contents. Okay, so it is nothing but it is a domain that tries to induce some kind of intelligence into machines and systems with the help of data and algorithms, and it enables a system to reason, learn, make decisions, perform optimization, and even generate contents. And as we know, the human intelligence itself is different, right? We are actually perceiving the human intelligence, or we are actually possessing human intelligence in different ways, right? So as we are having different ways to possess human intelligence in artificial intelligence also, we have different techniques to make a system intelligent. And the major techniques we always talk about while making a system intelligent is one is machine learning, which is nothing but learn from experience. Okay, which is learn from experience. Suppose if I ask you, like, what is the mapping of 10 if you are provided with 1 is mapped into 1, 2 is mapped into 4, 5 is mapped into 25, 4 is mapped to 16. What is the mapping of 10? Can you tell me what will be the mapping? I can tell that again. What is the mapping of 10? If you're provided with a data like 1 is mapped to 1, 2 is mapped to 4, 3 is mapped to 9, 5 is mapped to 25, 6 is mapped to 36. What is the mapping of 10?
100.
100, right? You are all able to tell me 100 is the mapping of 10, right? But I never said you that the second number is actually the square of first number, right? And how you are actually able to figure it out that 10 is mapped to 100? What happened in your brain? You have just gone through the data for analyzing what is the pattern that involved in it, right? And your brain is able to find out that pattern, and that pattern is further used for predicting 10 as 100, right? So this is exactly what happening in machine learning. I will elaborate it more Okay, then the second domain we need to tell is speech systems. Okay, speech systems. We are all familiar with Apple Siri or Google Assistant or the Cortana, Windows Cortana kind of applications, right? So they are all what receiving input in the form of audio or sounds and generating sounds as a response, right? So the AI systems which relies upon sound and audio is particularly known as speech systems. Okay, and the next one is computer vision. Computer vision is nothing but the AI techniques which relies upon visual data and information is actually called as computer vision. Can you just relate any of your application, any of the application you are using in day-to-day life with computer vision? In your mobile phone, there is a face detection system, right? In our roads, we have AI cameras that can detect whether a person is wearing a helmet or not, kind of stuff, right? So such kind of systems which relies upon visual data and information is actually called as what? Computer vision. And when it comes to natural language processing, we use textual data and information for making intelligence. The Google Translate, the Grammarly application, or even ChatGPT itself is an example of what? Natural language processing, right? The expert systems are very sophisticated AI systems which depicts or which adopt the expertise of a human professional, right? You may be experiencing some applications in the websites of bank. That is the most simplest example I can give for you. In the bank websites, you can actually have a chatbot, right? That we can ask our banking related queries to that chat application, and someone will respond to us, right? And do you think a person is sitting at the other end communicating with you? No, it is not the scenario. The system is actually mimicking a human personnel, that is like a bank professional, and communicating with you, right? Such kind of AI systems which depicts the human expertise is actually called as expert systems. We can see the expert systems in the form of AI doctors, AI advocates, and many more, right? And the planning and optimization is a very what narrow domain in artificial intelligence, which uses the mathematical and statistical and algorithmic techniques for performing optimization and planning kind of needs. The genetic algorithm, the heuristic techniques, all these things are actually coming under planning and optimization. And if you want to feel, or if you want to physically realize an artificial intelligence system, if you want to touch it, if you want to see it, see, there is something called robotics. So robotics is actually a domain in artificial intelligence which we can realize artificial intelligence as a physical entity, right? Hope it is clear for you. The machine learning, the speech, vision, the natural language processing, expert systems, planning and optimization, and robotics. And I would like to stress more on machine learning because machine learning is actually, as I said, it is a sub branch of artificial intelligence or a subdomain of artificial intelligence that focuses on developing algorithms and models that allow computers to learn pattern and relationship from data and improve their performance on tasks without being explicitly programmed, right? So the focus of machine learning is to identify the hidden pattern within a data. Okay, identify the hidden pattern within the data, and that pattern is can be further used for, okay, that pattern can be further used for predicting future outcomes. Okay, predicting future outcomes. So as you can see in this particular diagram, this is the data we have. We have a data regarding Apple and we have a data regarding orange, right? So a machine learning algorithm will receive this input, okay, will receive this input, okay, right? And it will learn about some patterns, okay, it will learn about some patterns. So here I can simply say, okay, the pattern here found is for Apple the color should be red, and for orange the color should be orange, right? So that kind of a pattern will be learned from or understand or figured out from this data, and on giving a new input with that pattern. So on giving a new input, it will first extract the color and check whether it is matching with any of the pattern. Yeah, it is actually matching with the pattern. The color is red, right? So it will say it is an apple. Okay, it is an apple. So this is exactly happening in machine learning. From the past data, the machine learning algorithms are actually trying to find out a pattern that connects the input and output, and that pattern is technically called as a model. Okay, model, machine learning model. And further, that machine learning model can be used to predict future outcomes. Hope that part is clear for you, right? So why I am stressing on machine learning is that, see, even though we are having this much subdomains in artificial intelligence and computer vision, planning and optimization, NLP, whatever it is, okay, whatever exists, I should say the 99 percentage of the applications, AI applications we are now experiencing is actually the applications of machine learning. Because even though computer vision, NLP, and other subdomains exist, to make a system or to make an AI system more robust and efficient, we always need to combine the techniques from machine learning into artificial intelligence. Okay. So all other subdomains of artificial intelligence. So whatever kind of subdomain we are choosing, if it is computer vision or NLP, we can see a big influence of machine learning on it. So I can collectively say the artificial intelligence domain is actually now getting dominated by machine learning. Or nowadays, artificial intelligence can be viewed as an equivalent of machine learning itself. Okay, so nowadays, if you want to incorporate artificial intelligence into your curriculum, you really need to incorporate what? Machine learning into your curriculum. Okay, so apart from this machine learning, the advancements like deep learning is actually nothing but it is a domain within machine learning which uses a kind of algorithms, a kind of family of algorithm called artificial neural networks, and an extended version of these artificial neural networks are actually known as a deep learning, right? Deep learning. And NLPs, as I said, NLP speech and vision, the reinforcement learning, the model deployment, all these things are actually the key technologies in artificial intelligence and machine learning when it uh, comes to realize it. Okay. And the wondering fact is that even though we are having all these stuffs within computer science, all these things are now applied in another domain that gives AI and ML a cross domain or an interdisciplinary application space. Okay, so we can see the influence of artificial intelligence and machine learning in healthcare, agriculture, finance, education, environment, humanities, everywhere we can see the applications of AI and ML. Okay, and mostly we are performing some forecasting, some prediction, optimization, and even content generation with what? Artificial intelligence and machine learning techniques. Okay, and the next major domain we have to understand is data science and big data. Okay, data science and big data. So what is actually data science? As the name suggests, is a science that deals with data, right? A science that deals with data. So do we really need to learn about data science? What is the need of starting a science that related to data? Do you think data science is much as important as you think? We can actually get evidence for this. Okay, you can actually get evidence for this because data is now termed as it is the new oil. Data is considered as the new oil. Why it is called as a new oil? Because if you look back in 10 years or 20 years back, the entire world economy itself is is actually controlled by one of the major commodity called petroleum, right? Petroleum products, right? But if you look into current industry space, you can actually understand that the petroleum industry is now not there, and the world economy itself is actually depending on data industry. Okay, data industry. I could say why it is happening. See, if you imagine about any 5 companies that makes huge revenue worldwide, okay, among that 5, at least 3 of them will be technology related company, right? Or the information technology related company. And one example will be definitely Meta. The other one will be Google, and maybe Microsoft or Amazon or Flipkart or some things, right? But just think about the case of Meta itself. Do you know how many employees are working in Meta? If you look into the statistics, there are around 30,000 to 35,000 employees are working in Meta. Okay. And let it be 30,000. Okay. And do you know what is the salary of a Meta employee? Average salary of a Meta employee, an entry level Meta employee. It is around 3 lakhs per month. Okay. 3 lakhs per month. And if you look into the revenue they need to generate to pay the salary to the employees, assuming all are entry level, it will be around 30,000 into 3 lakhs. It's 90,000 lakhs, right? Okay, 90,000 lakhs. And it is not a small amount. It is a very, very huge amount, right? But the question is, are you paying any single rupee to pay the applications of Meta, the products of Meta like WhatsApp or Instagram or this Facebook kind of things? Are you paying any kind of money for using such kind of applications? Definitely no, right? But still, Meta is managed to create such a huge revenue without getting any income from their product. So is there any guess how this is possible? Any guess? How Meta can generate this much huge amount of money even without getting a single penny from their products? Advertisements and data collection. So how this advertisements and data collection helps? See, if you look into the secret, see, I can tell you, see, while using the e-commerce applications, okay, e-commerce applications like Amazon or Flipkart or any other thing, okay, if you are actually going to purchase a particular product and with some reasons you are not able to buy it, you are just putting that particular product into the cart, okay. So what will happen if you're getting out from that Amazon or Flipkart kind of e-commerce applications, and when you log into your Instagram, after watching some reels, in between 2 reels you can see the advertisement of that uh, particular product, right? And again, if you are getting bored in Instagram and if you're switching to Facebook, there also you can see the advertisement of that particular product, right? The question is how Meta knows you have searched something in Amazon or Flipkart. They are 2 different entities, right? How this is getting possible? How this is getting possible? Yeah, the major reason is we ourselves. What is happening? We use the same credentials, the same email ID, the same phone number, everything in all these online platforms, right? So the applications like Amazon and Flipkart is not a simple application as you think. From where you are logging in, for what product you are searching for, what all products you have already purchased, what all category of products you are often looking for, okay, what kind of payment mode you are using, in what frequency you are visiting these websites, everything will get tracked, okay, every information will get tracked. And what is happening, all this information will get, all this data is actually getting tagged along with your email ID and phone number, and it will get pushed into the servers of this Meta, right? And Meta will do a lot of analytics on this data, and it will find out which product you are interested in, from which place you are actually logging in, or everything will get analyzed and find out the very useful insights from your data. And the email ID and phone number you have used for registering in Amazon or Flipkart will be used to identify your social media handles, right? And these social media handles will be used for publishing their advertisements to reach you, right? And do you think Meta will do it for free? No, the Meta will charge a huge amount, or Meta will generate a huge amount from this e-commerce applications. It's not only Facebook, not only Flipkart, or not only Amazon. If you look into the market, there are 10,000 kind of such applications are relying upon Meta for their advertisements. So it is very easy to make it easy for Meta to generate this much huge amount of revenue, right? So why I'm saying this particular example is I just want to make you convinced why data is important. Okay, why data become the future. Okay, and see then what is particularly this data science then? Okay, yeah. So what is actually this data science? As I said, it's a science that deals with data, right? A science that deals with data. So starting from collecting the data, okay, for starting from generating the data, collecting the data, gathering the data, storing the data, cleaning the data, transforming the data, wrangling the data, preparing the data, pre-processing the data, processing the data, analyzing the data, modeling the data, mining the data, and visualization of data, making applications out of data, monitoring the data. So if you look into the pipeline of data science, this is a very huge pipeline. Okay, it involves a lot of stages. Okay, it involves a lot of stages. So a single person cannot actually realize the entire pipeline of data science. Okay, a real pipeline of data science. So even though we are having this much stages, majorly this is divided into three different parts. The first part is actually called as data engineering. The second part is data analytics, and the third one is actually called as data visualization and interpretation. In data science, we are actually data engineering, we are focusing on preparing data for analytics. And in analytics, we are actually trying to find out useful insights from the data, and these insights are getting communicated to the end users in the form of visuals and storytelling. Okay, so this is how the data science pipelines are getting realized. Okay, so it enables us to data driven decisions and supports AI system with reliable data. And on the other hand, the big data is something which is again more sophisticated. Like the data nowadays we are handling is actually not a simple nature, because the data we are now handling is having actually so many challenges. The size of the data, the type of the data, the amount of data getting into a particular computing environment, all these things actually makes a data the big, and it will make the the nature of data to be handled with our with our traditional computing environment difficult. So we are actually having very sophisticated algorithms and infrastructure capabilities within big data environments, right? So these things are actually going to transform the future of technology, because we are into smart cities, we are into focusing on science, healthcare, business, right? Everywhere now the feed is actually data. For marketing, for analysis, everywhere we need data. For each and every process we are performing is actually generating the data, right? So as I said, irrespective of domain, we have a big opportunity to get into the data science for enriching our domain. Okay. And the next one is the next few you promising technology advancements like quantum computing is actually the next generation computing technique itself, because we are nowadays actually depending on classical computing techniques, right? The classical computing techniques are relying upon the electronic signals, which is actually in the form of binary data. Binary data is nothing but every data is represented using two different levels of voltages, that is a high voltage and a low voltage, right? And we can actually represent any data, we can actually represent any processing technique in the form of this ones and zeros and high and lows, right? But it has so much, it is actually having so much difficulties in representing this data only as zeros and ones, right? So the people came with a new computing technique, which is called as quantum computing, which where we can represent our data as a qubit, not as a bit, as a qubit. A qubit is actually nothing but it is a superposition of two different stages. Okay. So not only two different levels, we can actually represent n number of states, not only two states, n number of states with a single qubit. Okay. So that makes the promising speed ups for certain classes of problems. And the major constraint or the major challenge we are nowadays facing is nothing but we are actually ready with the algorithmic part and the theoretical concepts, everything, but we are still not able to realize a quantum computing physically that can work in a very natural environment. We have to keep a quantum computing in -degree Celsius to make it work. So the challenge is at the bottom level of this technology space. That is, we have algorithmic advancements, theoretical concepts, a lot of stuffs are there, softwares, everything is there, but we are actually facing what the realization of this particular system in a very natural environment. Okay. So the qubits, gates, circuits, noise models, algorithms, simulators, everything was there, but it is very difficult to realize it as a physical system in our normal conditions. And if you look into the applications, the cryptography, the chemistry and material science, the finance, optimization, everywhere, we can actually see the applications of quantum algorithms. And keep in mind, as I said, that algorithms, everything is now ready, but we need a physical system to realize all these steps, right? So that is the major challenge we are actually facing in the domain of quantum computing. Okay. And the other one is edge computing and IoT, and it is actually a part of this technology advancements happening in cyber physical systems. So IoT is nothing but it is a technology called as Internet of Things. So what is this Internet of Things? Internet of Things is actually a network of sensors, actuators, and other appliances like our computer, a car, mixie, washing machine, fridge, everything can be connected into this internet, okay, in a network way, and we can actually really control and make them work from the remote locations with the help of internet. Okay, so that is what we are calling as actually Internet of Things. And to realize Internet of Things, we need a technology called cloud. A cloud is nothing but one which technology that interconnects different devices from different part of the network, right? And usually what we are doing is we will simply connect each of the device into the cloud. But what is the challenge in that? Because the cloud become very heavy, right? The cloud become very heavy. All computations need to be happen in this cloud server. So what they have done is they created an intermediate layer which is called as edge layer. Edge layer is nothing but edge layer is a particular layer with a small computing device, and this computing device will do the local calculations, and only the results of the local calculation will be sent over the clouds. So the workload of cloud is actually got distributed into different edge servers. Okay, so as you know, you can actually track your health records that is captured through your smartphone, smart watches in a website, right? So within that device, there is a sensor, right? Okay, that sensor is capturing all the data, and that smartwatch itself is acting as an edge device. Okay, the smartwatch will compute all the things related to your health, and only the resulting data is actually sending to the central computing system. Okay, so that you can actually see that data from anywhere in the world with the help of internet, right? So this is what we are calling as edge computing and IoT systems. And you can see the key technologies we need to understand is embedded system, microcontrollers, HGI platforms, protocols. And here also we can see the healthcare, manufacturing, the smart cities, and agriculture systems are actually using this particular IoT and edge computing things. So have you heard about the smart agriculture, the smart cities? Everywhere you can see the the applications of IoT and edge computing. Okay. And the next one is extended reality. It involves the augmented reality, virtual reality, and mixed reality. Okay, so augmented reality overlays digital content on the real world. Okay, digital content on the real world. Suppose you can see a real situation, a real world scene, and if you watch that real world scene through a mobile application, you can actually augment objects, situations in the real scene, and you can see that through your mobile phone or any other computing device. That is what we are calling as augmented reality. Virtual reality is nothing but with the help of a device, we can actually get into a virtual environment itself. We were actually getting disconnected with our surroundings, and we are actually getting into the virtual environment, and we are actually interacting with that. Okay. And MR is actually the mixed reality is nothing but it blends the anchor virtual and real object interactively. Okay, so why it is actually important? It is powerful medium for experiential learning, simulations, and prototypes. And in foreign countries, we can see that the operations, the medical operations, the medical surgeries are actually happening with the help of this extended reality and virtual reality. So as I said, this is the real environment. Okay, so if you watch the real environment through a mobile phone, and you can see some artifacts or some augmented objects within that scene, this is what we are calling as what? Augmented reality. Okay, augmented reality. And in the case of virtual reality, we are getting into a reality, into a what environment, a digital environment, and we will get disconnected with our surroundings. Okay, and the real objects projected on and controlled in a virtual environment is actually here we can only see, but here we can actually control that. Okay, we can control that too. Then it is called as what? Augmented virtuality. So if augmented reality and augmented virtuality is together, then it is called as a mixed reality. Okay, and if it is augmented reality and augmented virtuality as well as virtual reality, then it together called as extended reality. Okay, extended reality. So hope this is clear for you, right? Is it clear? Okay, fine. And now we can actually look into the last one, not the last one, the second last one, that is the CPS and robotics. Robotics is actually evolved in a very gradual manner, right? First, we have the mechanical devices. Then the mechanical devices are actually implemented with electronic circuits and then it become the mechatronic devices, right? Then the mechatronic devices are infused with intelligence, then it become robots, right? And you can see the collection of such robots are interconnected together and working for a particular task in a very coordinated way is actually called as cyber physical system, right? So the tight integration of computing, networking, and physical process is actually called as what? A cyber physical system. And within robots, apart from this mechanical component and the electronic component, it can actually have some kind of perceptions, planning, and actuations in physical world. Okay, so there are sophisticated technologies that backing this robotic and cyber physical system domain, and the major one is actually called as ROS, robotic operating system slam control theory. And there are physical sensors and devices, the cameras, actuators, mechatronic uh, things, and the very algorithmic thing like planning, perception, and real-time systems are there to back up this cyber physical systems and robotics. And we can see the healthcare sector is now using the robotic surgery. The industry automation is actually enabled with this uh, robotics. Transportation systems like drone, autonomous vehicles are there. Agriculture, harvesting, everywhere we can actually see this applications of a CPS, cyber physical systems and robotics. And finally, after the LLM era, okay, the next thing is we are experiencing is agentic AI and autonomous systems. So agentic AI systems are actually software systems or an artificial intelligence system. Not only just generate content, it can actually do perceptions, planning, decision making, execution in a loop. Okay, in a loop. Suppose if we are assigning a particular task, it will particularly perceive the task, plan for a particular solution, it make decisions and execute, and it will evaluate itself. And if there is any kind of drawbacks or bugs present, it will again do this perception, planning, decision making, and execution in a very iterative manner until we got the proper results, right? So that is what we are calling as agent systems or agentic AI. And the agentic systems are now become the core brain of autonomous systems, because the autonomous systems need a kind of autonomy in their perception, planning, decision making, and execution, right? That is actually realized through this agentic models. Okay, hope this is clear for you. So these are the things I just want to make you understand about what all things are actually happening in the new technology and new computing space. Okay. Now, the second part of this talk is actually going to discuss about how we can incorporate these things into our curriculum, right? And you are all teachers, and we are all doing the teaching learning practice for a long time, right? So you can actually understand what are the challenges in traditional curricula, right? So what all things are outdated? The curricula often reflect technologies from 35 years ago, right? If you look into the syllabus of any subjects, okay, you can see the most of the technology reflections are actually cutting from years back, right? And it takes a long approval cycle, block rapid inclusion of new topics, right? So this is a major change. See, I can personally say still even now some colleges use that turbo C programming environment, that blue color turbo C programming environment to implement C programming. And why this is happening? This is not because of the students. This is because of what? The syllabus, the curricula, and the mindset of teachers. Okay, because we are not ready to adapt with the technology transformations happening in our surrounding. So as a result of this, we are actually very lagging. We are actually having a big lag in our in the inclusion of new topics and technologies into our curricula. And this is actually, I'm telling, irrespective of any domain. Okay. And the universities and other autonomous colleges are now getting more freedom, and they are actually doing it in a better way, but the controlled institutions are still lacking this pace of inclusion of new technology advancements in the curriculum as well as in the syllabus. Okay. And the minimal real world exposure. Few labs uses cloud GPUs, modern data stacks, and industry tools. And the projects often toy examples rather than a realistic data. Okay. See, these things, suppose, see, when you're teaching electronics, we always have a difficulty to make or to realize that concepts in a practical way, right? And we always complain like we don't have the lab facilities, we don't have the equipments, nothing, right? But how many of you are actually aware about applications like of Tinkercad, that we can realize any electronic circuits in a simulated environment as we do in a real situation, and we can get the outputs as in a real case. Okay, so such kind of things are actually not happening in our current curriculum. Okay, so these are the challenges we are actually facing in it. Okay, and the poor interdisciplinary integration, that is another thing. Even in universities itself, if you work, if you work together, like there will be a department of mathematics, there will be a statistics department, there will be computing, there will be some social science, there will be health sciences, biotechnology, physics, chemistry, everything. And as you know, everywhere we can actually see the applications of computing and artificial intelligence for advancing their research, right? But we are very hesitant to get involved and do interdisciplinary research. Okay, we are actually sitting in our own domain, and we are actually digging for knowledge. But a computer science person knows computing and AI well, but he is actually lacking the domain knowledge. And the domain experts are actually lacking the expertise of a programming or artificial intelligence kind of stuff, right? And we are actually not ready to mingle and gel with other people, uh, and to come up with interdisciplinary integration. So that is another challenge. And the other thing is the faculty skill gap. Okay, see, as you said, as you heard in my introduction, I was with Cochin University of Science and Technology, and currently I'm working with a startup. Why I need to go for that change? The one of the major challenge I faced is, see, most of the technologies students are now using is unaware to teachers, unaware to faculties. So we are actually far behind the students. So what I decided is I can just get into industry and learn about new advancements happening in that particular domain, and I can be uh, more efficient in a way that I can catch up with more technology things happening in the real situation. See, that skill gap, the filling of the skill gap is the another challenge we are actually facing. Okay, so how to integrate, how to mitigate these issues, and how, what all principles we need to follow to integrate these things. Okay, so the first thing is actually the agility and modularity. So what is actually agility? Agility is nothing but we have to frame or design a curriculum in such a way that the outcomes from that curriculum will be monitored and evaluated periodically. Okay, in a very periodically. We should have long-term goals as well as short-term goals, and the short-term goals should get evaluated. And if it is not actually competing, we have to revise the things and come up with new advancements, right? And the modularity is the, while breaking that into different outcome related tasks, the entire thing should be divided into different modules, and each module should perform a particular task, and that task should be defined with a specific set of outcomes, and that outcomes should be evaluated with a set of rubrics and portfolios. Okay, so that is actually a very needed thing, that is the agility and modularity in curriculum, when we need to incorporate computing related things, okay, or next gen computing related domains into your own curriculum. And the competency based learning is another thing, that is we should define clear skill, the PUs and COs. We are actually doing for the namesake, right? But we are actually not realizing it. Okay, how many, because even after the exams, the written exams, we are not correctly able to identify the attainment of the PUs and CEOs by our students, right? So that is also very important. And as I said, we need to follow, or we need to frame a proper set of rubrics and portfolios instead of only exams for realizing or incorporating this next gen computing things into your own curriculum. Okay. And the next one is industry alignment. Whenever we are actually designing a curriculum, keep in mind we we are actually on par with industry, because we are actually nurturing, or we are actually curating a group of students to get involved in the industry, right? Because they want to get a good job in the industry. They want, even after getting that job, they have to work along with the needs of industry. Okay, so whenever we are designing a curriculum, okay, so it should be co-developed modules, and it should include guest lectures, cloud credits. Everything should be incorporated within the syllabus, and we should always try to incorporate our particular domain with other domains, like the multidisciplinary aspects or the interdisciplinary aspects, like AI plus healthcare, data science plus social science. We are actually practicing this in the form of digital humanities, okay, AI for medical applications, such kind of things. The cross-listed courses and team projects with domain faculties are also a very important pointer when it comes to interdisciplinary pathways. And rather than actually doing or rather than actually simply delivering the theories and doing the practical lab cycles, you can actually get into a project-based and experiential learning, at least for the the subjects, or the at least for the domains which are incorporating along with computing things. The students solve semester long problems with real data and continuous integration. The data and the objectives are there for all domains, whether it is physics or chemistry or social science. Everywhere we can actually see, or we can get the real data and its need of getting analyzed, right? And what frameworks we can actually focus for uh, curriculum integration. See, if you look into a UG curriculum, if you want to include the next gen computing techniques into your domain, suppose it is physics or chemistry, whatever it is, the major things you have to focus is there should be a course on computational thinking that enhances the thinking ability and the programming ability of a student. Okay, so if you are trying to incorporate computing techniques with physics, you can actually offer a paper which is on computational thinking. Okay, computational thinking enhances the thinking ability in a computational perspective of a student to solve the problems in using different strategies. Okay, and definitely after the thinking process, it should be realized, right? And the most easiest and very adaptable programming language nowadays is nothing but Python. not only Python, you can actually choose your own programming language as per your applications, but most preferably, you can actually include Python as a programming language. And the computing techniques are not actually far away from mathematics. Okay, so there should be something which is discussing on the discrete mathematical aspects and its applications. Okay, so this will give a foundational ability for students, okay, on programming and computational thinking. Okay, with that ability, they always need to, when it comes to other domains using computing techniques, most of the time they have to deal with the data, right? To deal with that data, with to deal with that techniques, the one student should get equipped with statistics and visualization. Then such structured query language is just nothing but databases. Okay, databases. Okay, that is coming under data fundamentals. And the cloud fundamentals are the services, the technology and the infrastructure services available for us for performing this kind of computational and data tasks. Because even though you are having, you are knowing this programming or data fundamentals, to realize that in a very particular way, you always need to go for cloud environments and other complicated computing infrastructures. So the students should get what an experience with the cloud fundamentals, then they can actually make use of these cloud services very easily for their applications. This can be the foundational things that we can include in the first year and second year curriculum. And when it comes to third year and fourth year, because we are all practicing now 4-year degree program, right? Then in the third year and the fourth year, you can actually include the machine learning basics, the databases, maybe the networking and the security fundamentals, also the AI ethics and all for for the application purpose, not the core theory and all, because you people are actually using these techniques to apply it on a particular problem in your domain, right? So in a very application perspective, you can include these things as an elective for those who are interested with this. That is why we can put it as an elective. Then the semester project, you just ensure the projects done by your students should use advanced computing techniques, because if they get into the industry, you can actually see everything is actually happening with the computing devices, and nothing is happening in a very natural way. Everything is actually happening with the computer softwares and AI, right? So they should get an exposure to these applications, devices, and other technology advancements while doing their final semester projects and labs. Okay, so that is also very important. So the quick wins for UJ is add one cloud lab per course and use industry data set for at least 2 courses. These things are actually very useful when you want to incorporate this test and computing techniques into your own domain. Okay, and the suggested electives like the AI ethics, IoT systems, the XR, that is extended reality, introduction, data engineering, DevOps basics. This can be given into to any people irrespective of the domain. And when you do the project, try to follow the agile methodology. Agile is nothing but split the entire stages of the project into sprints. The sprint 1, sprint 2, and sprint 3. In the sprint 1, the student should clearly state the problem scoping and the data preparation. And in the sprint 2, they should follow model prototyping and development. And in sprint 3, they should get the essence of how they can actually transform their project into a product and the report and presentation. If you follow such kind of agile, after each sprint, there should be an evaluation and you can give the feedbacks, and that you can ask for rework on the things they have done on each sprint if needed. Okay, so if you follow a structure like this, the projects will get realized in a very quick manner. Most of the time, what we do usually practice is we'll just give the topic, and at the end of the semester, we will simply evaluate for the sake of evaluating it, right? But if we get involved, we teachers get involved in a very particular way, you can actually see that reflections in their project as well as in the understanding of the concepts. Because rather than simply mugging up all these theories, while doing these projects, they will apply that concepts they have learned in the classes for realizing or for solving a real problem. So that will give them more good exposure in the case of the practical aspects. Okay. And when it comes to PG curriculum, particularly whether it is an MSc Physics or MSc Mathematics or Agriculture, Social Science, whatever it is, see, the AI is now in need. Okay, AI is now in need. So the AI, ML, the data engineering, cybersecurity, robotics, quantum computing, these things can be specialized in the PG level as at least one subject. I say it can be done for every domain. And the research and industry integration is also can be done in a very particular way with this very specialized domains or the next gen computing things. And most of the time we can actually have a practice of co-supervision with industry partners. Okay, co-supervision with industry partners, because the facilities will get provided by the industry. The problems and the theoretical aspect can be supported by the institution. Okay, so that kind of things can be realized in the PG curriculum. And definitely the cross discipline opportunities are one of the major things. See, the medical imaging, predictive patient monitoring, bioinformatics focuses on the health and life sciences. If you come into business, humanities and laws, NLP for legal document, learning analytics for education, risk scoring in finance, all these things can be realized with the new gen computing techniques in business, humanities, and law, and in environment and agriculture, remote sensing, IoT based integration, crop yield modeling, these things. See, I can actually show you some case studies that applied in chemistry. Okay, and maybe it can be a biological application too, a bioinformatic application too. The protein structures, okay, the protein folding problem is actually solved with deep neural networks. It is actually, as I said, this is a very sophisticated AI technique, which is which is a, which can be considered as a subset of machine learning. Okay, the protein folding problem, and even there's something called graph neural networks where which can used for predicting the properties of materials, or we can actually make it used for material discovery. And see, the astronomical applications, the classification of galaxy, star, and all, or the anomalous event detection, everything can be done with the AI techniques, right? So this kind of interdisciplinary and cross-disciplinary applications can be done with our next generation computing techniques. And what are things should happen in the teaching learning enhancement? See, the teacher should use AI enabled tools. Okay, the teacher should use AI enabled tools, the LLMs for drafting, learning materials, code hints, and adaptive feedbacks, auto grading for codes and notebooks, these things, and the cloud based virtual labs, pre configured virtual machines. These things can be actually used for in a very particular way. And the teachers should be equipped with flipped classrooms, peer instruction, live coding sessions and labs in teams, and ensure that even if they are non-computer science students, try to use the GitHub, Kaggle notebooks, Google Colab, Binder kind of applications for doing their experiments and keeping their portfolio very rich. And the assessments also, the project portfolios, reproducible codes, everything can be done in a very modern way. The teachers should get equipped and they should adapt the modern technology tools for enhancing their teaching learning practice. And the implementation model, as I said, the 4-year transformation map, the first year we can actually give the foundations plus small labs. The core applied modules can be done with industrial expert lectures in the second year. The specialization had capstone scoping with partners, and the project capstone projects, internships, and micro certifications can be executed in the fourth year. So if you execute the entire thing in using this implementation model, even if they are from a very discrete domain like physics or chemistry or life science or any other domain, they can actually get equipped with an industry ready uh, computing abilities, because the industry is actually wanting these kind of skills to enhance or to execute their projects and to enhance their productivity, right? So what is usually happening is we will just make them learn all the theories, and they have to learn these things after getting a job. But our responsibility is to make them ready for industry, right? So if you integrate, but this is one of the major solutions I am just proposing. If you try to incorporate the next gen computing techniques along with your curriculum, definitely you can actually change, you can actually see the change visible. Like your domain knowledge and the computing ability you are providing for the students will make a big change in their future. Okay, so this transformation roadmap will definitely give you an insight of how we can actually execute this particular plan. And the micro credentials and industry tie-ups are actually very, very important. Even for institutions, you can actually think of making center of excellence by shared labs, GPU pools, and joint faculty appointment kind of stuff. And the sustainability concern is there, then the budget for cloud credits, hardware replacement, and personnels are actually a concern. But we can actually solve these problems by collaborating with other institutions for sharing the resources. Okay, and the core part of this, how we can actually realize this, is actually a challenge, and that can be realized or that can be solved without any shortcuts by only equipping our faculties with enriched contents and abilities. Okay, so we have to to conduct a lot of faculty development programs and faculty readiness programs. Okay, to make the teachers, okay, to make the teachers equipped and enabled with new technologies and new advancements in their area. And for that, there should be short-term courses, there should be sabbatical leaves with industry, there should be co-supervision, certifications. These things should be ensured for all faculty members in your institutions. And the partnership with research labs and industry mentors, faculty exchange programs, and visiting industry fellows are also a very added advantages to develop our faculty and make them ready for it. Okay, so these are the very crucial points, and we are actually reaching to the end. And as a concluding remarks, I just want to tell you the future of education is dynamic, interdisciplinary, and tech driven. So integrating next gen computing is very essential, not actually optional. Okay, and start with small elective workshops and sandboxes. And as I said, the strength of faculties and the industry partnership is one of the major uh, one of the major focuses. And empowering students for global opportunities will make our educational system comparable to global standards. Okay. And again, I'm telling one sentence that I started with to conclude it. Computing is no longer just a discipline, it has become a fundamental tool for exploring and advancing every other discipline. So thank you for patiently listening for this much time. Okay, I think it's around 7:54. We can actually open up for question answering sessions, and you can actually get my contacts from this. If you have any concerns or if you need any clarifications of even if you need any kind of help on this technology things, you can actually connect with me. So thank you for the patient listening and being interactive while session. Okay, try to connect in LinkedIn if possible. We can actually have interactions, and you'll get informed with different sessions happening over here. And I'm sharing a lot of things related to artificial intelligence and data science in LinkedIn. So thank you. So organizers, you can actually open the floor for any questions. You can actually put any queries. In the chat box also. Otherwise, you can unmute and ask.
So thank you for the innovative session, sir. So I have a simple doubt related with JIT classrooms and JIT workflows. Can you please brief those concepts of JIT workflows and JIT classrooms?
Yeah. So JIT, hope everyone is knowing what is JIT. I will tell you one profile. Is my screen visible now?
No, sir. Yeah.
I'm sharing my screen. Is it visible now?
Yeah, yes.
This is one of the JIT profile of one of our students. Okay. See, what is the need of a JIT profile and what are things actually we can do with it. Okay. See, he's actually an MSc computer science student. Okay. Specialized in AI and data science. Okay. See, on seeing this his profile itself, you can get an impact of how he is actually doing well. Okay, so this is his profile, and here you can see the activities here he is doing. Okay, and the people are actually the industry people are actually looking into this kind of profiles very importantly, because if you look into his thing, see, in 2001 he started doing activities with JIT. Okay. And in 2022, 23, 24, 25, these things, this will directly indicate, okay, this will directly indicate his active participation in coding and technology space, because these green points are actually indicating how much he is actually getting involved in the coding and how much he is contributing into the JIT. So JIT is a tool, is, or it can be considered as a version control tool. Okay, version control tool. And this version control tool is used to keep your codes, okay, programming codes, in a very safe manner over the internet. Okay. And in our university, we practice a particular thing. See, you can actually see one repository which is related to Python programming. Okay. So we have a lab in the first year, Python programming, and we usually don't keep rough records. Instead, what we are actually telling is, see, they have to keep their code. Okay, they have to keep their code in the GitHub, the lab cycle one, the question one. They will keep the programs. Okay, they will actually keep the programs and the outputs within the within the JIT itself. Okay, and we ask students to submit the JIT record, this JIT link, for submitting their lab works. And we can, there is an accountability. We know when it is getting uploaded. Everything will get tracked here. Okay, so this is particularly what we are calling as JIT workflow. Okay, JIT workflow is nothing but we can make it as a personal solo workflow. We can just keep codes in our laptop. We can push that code into a particular JIT account, and from there we can actually even deploy our applications. Okay, when we are doing a projects or something. Okay, and it is what we are calling as CI/CD pipelines. Okay, and JIT classrooms are actually, some facilities are there. If while submitting this applications codes to ourselves, there is a facility to automatically evaluate this code and grade, and we can actually perform the unit testing. We can actually input output testing. All these things can be done in a very automated way with JIT. So it makes our lab evaluation, every process, very easy. So that is what we are calling as JIT classroom. For computing people, this is a very helpful tool. Hope it is clear, sir.
Yeah, exactly. Thank you very much. Yeah.
Sir, please give examples of AR, VR, and MR. Okay, I can show you one example. Let's see. AR versus VR versus MR. Are you able to see this image? Are you able to see this image? Can anyone respond?
Sir.
Yeah. So this is a real environment. Okay. This is a real environment. And when I look into that real environment with a with an application by opening a camera, you can see the real environment in the screen. And along with that real environment, you can see some augmented informations. Okay, you can see some augmented information. Okay, so this is what we are calling as augmented reality. Okay, so it is only visible through a particular computing camera device. Okay, but virtual reality is nothing but, see, you will be able to get into a virtual environment if you use a kind of device. Okay, if you can use a kind of device. Okay, and you will get isolated from the surroundings. Okay, if you just wear a glass and you will be within a zoo and you can see the animals, everything on there, but you are not able to interact with it. Okay, you will not be able to interact with it. And when it comes to mixed reality, you can actually get into a world, and within that world, you are able to interact with them. Okay, you can actually interact with that particular scenes you are seeing on it. Okay, how it is clear, I think. Still, you have doubt? Serena TM, is your doubt clear?
Yes, sir.
Anand Kumar Singh, how can artificial intelligence be used to eliminate middlemen in agriculture supply chain, ensuring the farming receive fair and full payment for their produce? See, that is actually a challenging question. We can actually automate a lot of, because the online platforms, maybe you can see, right? Some online platforms are readily available there. We can actually market our own produced items to end user customers. Okay, and that is a platform. Okay, that is a platform. Artificial intelligence actually can be applied for, as I said, there should be three use cases: to optimize, to make decisions, and to even generate contents. These are the three focuses of artificial intelligence. So if you have multiple platforms like this, okay, for selling different products, one way we can do is we can make use of artificial intelligence to optimize our selling. Okay, optimize our transaction process across different platforms. How can I get the maximum profit by selling how a particular amount on this platform, on other platform, kind of stuff. So likewise, you can actually automate different processes in supply chain with the case of artificial intelligence. But we need a platform. Definitely, we need a digital platform for enabling all these things. The intelligent part within that platform can be realized with artificial intelligence. As in every talk I say, AI is not a solution for all problems. AI is actually used particularly for decision making, optimization, and content generation. Okay, please suggest some tools that will helpful for academician. Definitely, there are a lot of tools. I will quickly tell some of them. The first one is Google. Okay, if you're noting down, I will show you one thing. Google's Notebook LM. This is a very important tool. See, this is a very important tool where it will help students as well as teachers to study and learn very efficiently you can actually see a lot of application. As I'm not having much time, I'm not explaining what are functionalities, but you can actually get into this and explore this too. Notebook LM and Canva is another one to make presentations. Then LaTeX, LATEX, LaTeX is another tool. See, I have created this entire presentation with the help of AI. Okay, with the help of AI. Even the images are even created with AI. For that, I have used ChatGPT and LaTeX for preparing this. Okay, so the notebook LM, LaTeX, ChatGPT kind of LLMs. Then Grammarly is another tool. Canva is another tool. Okay, and a lot of other generative AI tools available for making programming. You can rely upon Perplexity and Cloud and Copilot. So a lot of tools are there. If you look into a simple search, even if you can ask for the ChatGPT itself, what are tools available. And the one major tool I should recommend is Google Notebook. Yeah, I can share my PPT with the coordinators. They will actually give you this slides, or even you can directly connect with me. I can also share. Any other questions? Yeah, see that what I said. As we are running out of time, I just skipped notebook column. See, I can show you some example. See, this is one of my research papers. Okay, classifying Indian classical dance food posters with AI. This is my research paper. Suppose you want to read this and understand the concept explained in it. Okay, so what you will usually do, what you can do, you just take a printout of this paper, or even in a laptop, you will just start reading and note it out these things, right? But here, what is happening? See, if you look into this, you can listen, right? What is happening is the entire paper is actually converted into a podcast. Okay, that podcast is discussing the entire paper, and we can actually listen to it for understanding what is discussed over it. Okay, that is an interactive thing. Then see the quizzes created from this very easily. We can actually create quizzes on this, and this is particularly called see, the entire content of the paper is actually created as a mind map. This is not like a chat GPT or something. The everything can be tracked in a very interesting way. Okay, so this is mind map. So the audio is there, the poster quiz is there, then mind map is there. See, this is also, yeah, that's also audio. Even you can create a video presentation with this. See, and you can actually again create infographics, slide decks, flashcards, reports, A lot of options are actually available, and you can also use these things in your own native language too. So this is particularly very interesting tool and very sophisticated one and having a lot of applications. Any more questions? I'm very happy that still the participant count is 164. You are very keenly watching the interactions, because most of the time when the session is over, everyone will get logged out. Here I can see 164 participants still remains here. So thank you. So organizers, if there is no further questions, we can actually wind up. And maybe some of you can actually unmute and give some feedbacks too, because this is a very new topic I'm engaging apart from the core technical ones. So if I get some feedbacks from your side, whether it is positive or negative, it will also help me to make it more proper for the next time. Anyone, please. For lab sessions, for programming lab sessions, there are a lot of tools now available, ma'am. Like CodeChef is providing some tools, and I'm just to look into online platforms. Yeah, online GDB is another one. CodeChef is there, lead code. All these things are the Replit is another important good application we can make use of. And for this electronics and mathematical applications, you can use this Tinkercad. Tinkercad is another tool. Okay, you can do 3D structuring kind of stuffs in this Tinkercad. And there is, for mathematic people, there is a very interesting tool which is called as Desmos, graphing calculator. These things are actually very useful tools for making the classes more interactive and even executing the apps. See, there are 162 participants. I just want to get one or two feedbacks from your side. It will be very kindful.
Good evening, sir. This is Vijay Lakshmi. I'm management faculty. Though from an non-technical background, I was able to comprehend your session from the scratch till so many dimensions of artificial intelligence, starting from data science. You dealt it very well, sir. I really like the pattern you explained, that 100 as an example, final example, because we need some strategies as to how to connect with the data science. It's not like the other management subjects. It's little technical for us, but your examples of understanding, simple example of pattern was very interesting. Thank you very much, sir.
Thank you, ma'am. Any more?
Yeah, good evening, sir. This is Dr. Immaculate Mercy from Periyar Institute of Science and Technology. It was really a well-driven session wherein we get lots of insights about how we can integrate artificial intelligence tools in our teaching, especially like advanced pedagogy and all those things. The main concern these days is that the students never get into the practicing of writing the codes. So they try to get the codes from the tools, and this is a matter of concern. So we got to think ways and means wherein we can bring in the talents together, wherein we can bring in the coding talents in the students, so that it could be helpful in the future. And your session was really interesting, sir, wherein we can bring the minds together and we can build an intelligent future.
Thank you. Thank you. So coordinators, I think we can wind up the session. Anyone from the Majlis College online?
Hello, sir. Am I audible?
Yes.
Good evening to everyone. Join us online. This is Jabir, Assistant Professor, the Department of Computer Science, Majlis College Autonomous. Let me uh, present a simple and clear summary of today's technical session, Bridging the Gap and Integrating Next-Gen Computing into the Curriculum. It's a part of today's reporter. The session was handled by Dr. Sailesh Shivan, an experienced AI architect and researcher with a strong work in AI, machine learning, data science, quantum computing, and modern computing systems. His background in industry and academics gave solid weight to everyone who entered his present. Actually, why these topics is important. At the beginning of his presentation, pages 4 to 5, he explained the technology is changing very fast, and today's industry experts expect skills in AI, cloud computing, cybersecurity, quantum computing, extended reality, and IoT and edge devices. Our education system must catch up with these rapid changes. And secondly, what the next generation computing means. He clearly listed the major next gen areas, pages 7 to 8, AI and machine learning, data science and big data, quantum computing, edge computing and IoT, augmented reality, virtual reality, and extended reality, and cyber physical system and robotics, cloud, native technology, and agentic AI and autonomous systems. These domains are already shaping the job market and the global tech ecosystem. And third, the major problems in your present curriculum. From the pages 27 to 28, he highlighted the main issues. Syllabi becomes outdated quickly, and approval procedures are slow. Students get very little real world or industry level practice. Lab does not need modern tools, cloud GPUs or large data sets. Interdisciplinary learning is weak. Faculty training is not kept in place with the new technologies. These challenges directly affecting the quality of graduates coming out of our institution. And fourthly, the principles models for improving the curriculum. He's also explained how institutions can be upgrade their programs, pages 30 to 35. Use modular, easy to update courses designs, focus on skill-based learning rather than only exams, include industry supported models and micro certifications, and introduce project based learning using real data sets, include cloud labs and modern tools are part of the regular teaching. These even provided single frameworks for both UG and PG programs, showing how subject labs and projects can be structured semester by semester. And fifthly, improving teaching and learning, pages 42 to 43, he's listed many useful tools for modern teaching, AI tool for content preparation and code assistance, auto grading system, cloud-based virtual labs, GitHub classrooms, Google Colab, Kaggle notebooks, flipped classrooms, peer learning, and continuous assessment. These methods make learning more practical and engaging. And finally, sixth one, implementation roadmap and faculty development. And he has also explained a 4-year roadmap, pages of 45 to 48 institution instructions. Start with pilot module, slowly add columns, slowly add cloud labs and industry project, create uh, centers of excellence, and provide communication training and FTP for the faculties, and encourage collaborations with the research and industry. This is the part directly connected with his own experience of conducting more than 160 plus workshops, training program for
Wow.
teachers and professionals. Final takeaways. The main message of this session was simple: next generation computing must be the part of the curriculum. It is no longer optional. Its institution doesn't update. Students will fall behind in a fast moving world. Then I sincerely thanks Dr. Sailesh Shivan for an informative and practical session, Mr. Manchula H for coordinating, and Mr. Subhash VP for managing the technical support on the Zoom platform. And this brings the reporter summary of today's technical session one to you a close. Thank you. Thank you so much, sir.
Thank you.
I would like to invite Manchula ma'am for the formal vote of thanks.
मम्मी तो हो पड़ती नहीं हूँ उठाए नहीं थे
स्क्रोल કેમ કરેલો participants
अरे
Hello.
Yes, ma'am. You are audible. Manjula ma'am, you are audible.
Okay, thank you, sir. So, respected dignitaries, faculty members, and dear participants, I'd like to extend a sincere vote of thanks on behalf of Majlis Arts and Science College, Pormannur. It's my pleasure to extend gratitude and big thanks to our resource person, Dr. Sailesh Shivan, Principal, AI Architect at Lenek AI, for his expertise and insightful talk on bridging the gap, integrating next-gen computing into the curriculum. Thank you, sir, for enlightening us on how we will incorporate next-gen computing into the curriculum. Next, I would like to thank Dr. Nazir Ali MK, Head Department of Education, for the welcome address. Next, I would like to thank Mr. Mohammad Jabir PK, Assistant Professor, Department of Computer Science, for being the rapporteur of this session. And next, I would like to thank our